Welcome back to the Deep Dive. Today, we are really trying to unlock the architecture of modern AI. Specifically, how these advanced systems manage to pull in real time, up-to-the-minute information from, well, the entire web. Moving far beyond their original training data. We're doing a deep dive into something called the Model Context Protocol, or MCP, and this pretty sophisticated six-step workflow it powers called Agentic Retrieval Augmented Generation, or RA.
Which is a mouthful.
It is a total mouthful.
Yeah.
Yeah, a lot of alphabet soup there.
Yeah.
But don't worry, our mission today is to make it all crystal clear. The goal here for you, the listener, is to really get the core architecture that lets an AI mix its static internal knowledge, its memory with dynamic external data, the ability to just look something up right now.
Which is how you get those highly accurate contextual responses we all demand from AI today.
Exactly. Okay, let's unpack this.
Yeah, and this is such a critical topic because, the difference between a good AI response and a great one, it often just boils down to situational awareness. This architecture isn't about just finding info faster. It's about making an intelligent decision on what information is needed, where to get it from, and then how to combine it all. And that's where the Model Context Protocol, the MCP, comes in. It's the enabling tech here. It's basically the rules of engagement for how context gets shared.
So not just a simple data pipe?
No. Think of it more like the central nervous system that's coordinating all these really complex data requests.
And at a high level, what does that coordination get you? What's the big promise of using an MCP-powered workflow?
The promise is true. Seamless querying. It's deep, real-time context integration, and, this is important, making the responses intelligent. So they're synthesized, not just, copied and pasted.
Yep.
And when you break down the actual structure, you've got three core components. There's the MCP client, the MCP server, and then all the different data sources.
And based on the sources we looked at, it really seems like the MCP server is the one doing all the heavy lifting. It's kind of the brain of the whole operation.
That's it, exactly. The server is that central coordination layer. It takes the request, it figures out what resources it needs, which internal database, which external web scraper, and then it just manages the execution and synthesis of all those results. It's the conductor of the orchestra.
I like that analogy. So let's follow that conductor through the performance, starting with the very first notes. Steps 1 and 2 of this workflow. Step 1 is query initiation. This is where it all begins. A user, usually a developer or maybe an app, inputs a question from their environment. Our source material mentioned interfaces like Cursor being a common starting point.
And that's where the MCP client's role starts. The client is, it's pure communication. It just receives the query, it packages it up, and gets it ready for transmission.
So it's not smart, it's just the mailbox.
Exactly, it's just the mailbox that sends the letter.
Okay, so once that letter's in the mail, the client passes it off. That brings us to step 2. Server coordination. The client forwards the request to the MCP server. And this is where a simple lookup process stops, and that agentic part we mentioned really starts to kick in. The server's job here sounds critical. It's managing requests, orchestrating tools, and deciding which data sources it needs. But wait, why is that decision so important? Couldn't the system just, check all the data sources all the time?
That's an excellent point, and it's actually what separates agentic RGRAG from simple RGAG. A more traditional system might just follow a rigid path. Always check the vector DB, then check the web API, no matter what you ask.
Right.
The agentic part means the server is intelligently coordinating based on what the query is actually about. If you ask, what's the historical average rainfall in Seattle? It might decide, okay, I only need the internal historical knowledge from the vector DB.
But if you ask something different...
Exactly. If you ask, what's the price of Bitcoin right now? It knows to skip the internal memory and immediately trigger the live web retrieval tool. That intelligent decision saves massive amounts of computation. And, crucially, it cuts down the wait time for the user. Its efficiency and relevance married together.
So the server is acting like a really skilled research assistant who knows exactly which book to pull off the shelf without wasting time.
That's a perfect way to put it. It prevents resource waste and it ensures speed. And if the server makes a bad call, like if it fails to see that it needs real-time data, that's when you get an AI that's hallucinating or giving you an answer that's technically right, but, totally outdated.
Wow, so the precision of that step 2 decision is everything.
It's paramount.
That's a fascinating layer of smarts built right into the protocol. Okay, so we've got our central coordinator. Now let's get into the real action context gathering and enrichment. That's steps 3 and 4. This is when it actually goes out and gets the data. And step 3 is where it gets, I think, really interesting, external data retrieval. To give a real-time answer, the MCP server has to go look outside its own walls.
And this is the capability that ensures the system is, currently aware. The source material specifies that this external retrieval is done via Bright data.
And what is Bright Data doing exactly?
It functions as the scalable, real-time web search and scraping engine. And the importance of a dedicated, high-capacity tool like that, it just can't be overstated.
Okay.
We're not talking about a simple Google search API here. We're talking about robust, really scalable ways to extract structured and unstructured data from the live, constantly changing web. So if the query is about a huge market shift that happened like a minute ago, this is the tool that makes the AI immediately aware of that situation.
Let's make that practical. So say a developer asks the system to summarize the latest regulatory changes in, I don't know, the finance industry. If those rules just got published 3 hours ago,
Right.
the AI needs to completely bypass its internal training data, which might be months old, and go scrape the government and news sites right now.
That's precisely the implication. If you skip step 3, you end up providing historical data that's pretending to be current information. So this live retrieval is just the foundation for any kind of time-sensitive task.
Okay, now step 4 happens at the same time, which is the context integration phase. So while Bright Data is out there scraping the live web, the MCP server is also gathering other contexts.
Yes, and this simultaneous retrieval is key for speed and for getting a complete picture. In step 4, the server's pulling from 2 other crucial sources. The first one is the vector database context.
Can you tell us a bit more about that? What's a vector database, and why does the source specifically mention Qdrant as the tool here?
Sure, so a vector DB is all about semantic relevance. It's not like a traditional keyword database. It stores information as what we call embeddings, which are basically numerical representations of concepts and meaning.
I see.
And Qdrant is used because it's optimized for incredibly fast vector search. It finds data that is semantically relevant to your query, not just stuff that contains the same keywords.
So that's the system's institutional memory.
That's it. If you ask about market stability, the vector DB uses Qdrant to find all the historical documents related to economic indicators, definitions of stability, known patterns. It doesn't matter if you use those exact words. It ensures the response is grounded in established facts and deep long-term knowledge.
So if step 3 with Bright Data gives us the latest breaking news headline, step 4's vector DB gives us the 50 years of economic theory we need to actually understand that headline.
Exactly right. That's the stable knowledge base. But step 4 also has a second stream, the general web context layer. And this is where it can get a little blurry for people, but it serves a very specific enhancement role.
I was just about to ask. I mean, if Bright Data already scraped the web in step 3, what's the purpose of this second web context layer in step 4?
It's a great question. They serve different purposes in the workflow. Step 3, powered by Bright Data, that's often a really targeted, heavy-duty scraping operation. It's getting the raw, specific, high-volume, real-time data for the core of the answer like stock prices or a specific legal text.
Got it. The main payload.
The main payload. The general web context layer in step 4 is more about grabbing broader dynamic web data. Things like supplementary definitions, supporting links, or just general contextual snippets that enrich the results from step 3. It's less about the core data and more about providing a richer, fuller context package before everything gets consolidated.
Okay, so it's making sure all the angles are covered.
Pretty much.
If we connect this to the bigger picture then, the key insight is that the MCP server isn't just, checking boxes, it's managing these parallel data streams. It's bridging that stable internal knowledge from the vector DB with a dynamic real-time context from the live web.
And that simultaneous blend is the true hallmark of an advanced agentic RG system. It creates a response that's not just accurate, it's layered. It has the depth of history and the freshness of this exact moment. That seamless combination is where the real value is for the user.
Okay, so we finished the whole R-rigged retrieval part. The server is now sitting on a massive pile of context. It's got the initial query, the real-time scrape data, the deep historical knowledge, and supplementary web context. So now we get to the final phase, steps 5 and 6, consolidation and final delivery. Step 5 is consolidation. This feels like the most complex cognitive step for the system. Taking all those different threads of information and weaving them into one single coherent answer, How does the server even manage that?
This is where that agentic architecture really earns its keep. The MCP server doesn't just staple the data together. It has to apply some pretty sophisticated synthesis algorithms. It has to recognize conflicts. It has to prioritize the time-sensitive data over historical data where that's appropriate. And it has to structure a narrative.
So it's acting like an editor.
Think of it like a chief editor. Exactly. It gets a report from the internal archives, the vector DB. It gets a frantic memo about a live market event from Bright Data. And it gets some helpful background notes from the web context. The editor's job is to weave all of that into a single, cohesive article that directly answers the user's initial query.
Wow.
Complete with citations and proper context.
That is a heavy lift. I mean, it's merging this time-sensitive, structured data with the often messy, unstructured data from the web, and the final output has to sound like a single, authoritative voice.
Exactly right. And the result of that consolidation is what our sources call the fully contextualized response. It's not just a collection of facts. It is the answer, enriched and synthesized. And that payload is the final package that gets sent back to the MCP client.
Which, of course, brings us to step 6, delivery to the developer. The MCP client, which started as just the mailbox, now acts as the destination, delivering that final consolidated response back to the app or the person who asked the question in the first place.
And because of everything that happened in the first 5 steps, the quality of that final response is just inherently different from a simple database lookup. It's guaranteed to be contextual, accurate, and enriched with the most current information available, all integrated with the model's deep knowledge base.
So from the developer's point of view, the practical benefit here is huge. Instead of them having to run multiple searches and manually cross-reference things, they get one high-precision answer they can actually rely on.
That's the utility. The sources highlight that this level of context lets developers move forward with confidence. They aren't guessing if their internal documentation is fresh enough or if the web data is accurate. They know the system just gathered, compared, and synthesized all the relevant data points for them.
Which brings us full circle.
Yeah.
So what does this all mean for someone listening? We've walked through a 6-step process that turns a basic question into this sophisticated, highly contextual answer using intelligent orchestration.
It really showcases the power and flexibility of this kind of workflow. It's a complete life cycle for adaptive query handling, and it can manage complex tasks that simpler RG systems would just choke on because they can't coordinate all these diverse, time-sensitive sources at the same time.
And we saw how that relies on integrating some really specialized tools. We had Cursor as the user interface, Quadrant providing that lightning-fast vector search for the internal knowledge,
Institutional memory.
and Bright Data enabling that scalable real-time data retrieval from the web. The coordination of that tech stack is what makes the whole system run.
It is. It's the definition of a distributed system working in harmony. And I think as we wrap up this deep dive, the final thought for you, the listener, should really be about adaptability. The core lesson here isn't just the speed, it's the system's ability to change its strategy based on the query. The model context protocol, by integrating these simultaneous, distinct data streams, that static, high-integrity vector DB and the dynamic, rapidly changing live web, it lets AI systems move past simple recall. They can actively adapt their response in real time as the world changes.
That situational awareness, that feels like what separates the next generation of AI from everything that came before.
Absolutely. Just, consider the types of truly adaptive decision support AI systems that become possible when that barrier between a static internal database and the dynamic live web is just completely removed. It unlocks a whole new realm of highly accurate, personalized, and actionable intelligence that we're really only just beginning to tap into.
A phenomenal look at the nuts and bolts of modern AI systems. Thank you for joining us for this deep dive. We hope this helped you understand how the Model Context Protocol is enabling these scalable, intelligent, and truly data-rich AI workflows.